Welcome to The Explainer. Today, we're going to talk about something you've probably never seen, but it is everywhere. It's the hidden brain that runs basically every factory, every power plant, you name it. It's the secret behind modern industry. So let's just jump right in with a big question. Think about it. How does a piece of software, something running on a computer in an office, actually control a massive 10-ton machine out on the factory floor? How do we get from a mouse click to real physical power?
Well, to figure that out, you've got to look at how a modern smart factory is built. It's not just one giant thing. It's actually a stack, a set of layers all working together. You've got the business planning stuff way up at the top, and the actual machines doing the work way down at the bottom. Okay, take a look at this stack. See? Up top, you've got your ERP systems for business planning, down below, the machines. But what about that question mark? There's a huge gap right there at level 2. Something's missing. What's the thing that takes an order from the manufacturing software and tells a robotic arm exactly what to do? Right, that missing link, that's our hero for today. It's the Programmable Logic Controller, or as literally everyone calls it, the PLC. So, what exactly is a PLC? Well, it's a computer, but trust me, it's nothing like the one on your desk. This thing is an absolute tank. It's rugged, designed to get beaten up on a factory floor, heat, dust, vibrations, you name it. It was created to replace these gigantic, crazy complex electrical panels from the old days and give us precise digital control. And here's the magic trick. Your laptop, it runs on a tiny bit of power, like 5 volts. A huge industrial motor, we're talking hundreds of volts. You can't just plug one into the other. That would be bad. So the PLC acts as a safe middleman. It's an intelligent translator. It takes a small, safe signal, usually 24 volts, and uses it to boss around the big, powerful machinery without anything blowing up. Okay, so how does this thing actually think and act? The easiest way to get your head around it is to picture the PLC as a little robot person. It has senses to perceive the world, a brain to make decisions, and muscles to take action. And it does this in a super fast, non-stop loop called the scan cycle. It just does 3 things over and over and over again, thousands of times a second. 1, senses. It checks everything around it. 2, brain. It thinks about what to do next based on its programming. And 3, muscles. It acts. So senses, brain, muscles. Let's dig into that. First up, the senses. In PLC speak, we call these inputs. These are just signals coming in from the real world. Things like, is a button pushed? Did a sensor just see a box go by? Is the safety gate shut? The PLC is constantly checking all these inputs, getting a complete picture of what's going on. And then you have the muscles, or what we call outputs. After the PLC's brain makes a decision, the outputs are the actions it takes. It sends a signal out to, start a conveyor belt, turn on a big red warning light, fire up a robotic arm. You get the idea. This is how it actually controls things. Okay, so what about the brain? How does it decide? Well, it's just following a program. But here's a cool part. The language used isn't what you'd expect, like Python or something. The most common one is called ladder logic. And it's visual. It's actually designed to look like the old electrical diagrams it replaced, which made it super easy for electricians to pick up. All right, let's look at a real-world example to make this concrete. And it's a super important one, safety. Picture a giant industrial paper cutter. I'm talking a heavy, razor-sharp blade that can slice through a phone book. Obviously, you do not want an operator's hands anywhere near that thing when it comes down. So the safety rule is dead simple, and there's no getting around it. For that blade to move, the worker has to have both hands on 2 different buttons that are placed well away from the danger zone. That way, their hands are physically occupied and safe. This is a perfect job for PLC logic. The rule we program is a basic AND gate. It's just if the left button input is on and the right button input is on, then activate the output for the blade. The second either one of those buttons is let go, the AND condition is broken, the output turns off, and the blade immediately stops. It's simple, it's lightning fast, and it's rock-solid reliable. But look, modern factories are about more than just on and off. That's just the start. If you want to make a factory truly smart, you need way more than just yes or no information. You need data. You need details. And this is where we have to talk about 2 kinds of signals. What we've seen so far with the buttons, that's a digital signal. It's either on or it's off. Simple. But most of the real world isn't like that, right? Think about temperature or pressure
or how fast a motor is spinning. These things aren't just on or off. They exist on a scale. We call those analog signals.
And modern PLCs are smart enough to handle these too. They have special input cards that can read an analog signal, say from a temperature probe, and turn that physical reading into a number. So it's not just hot or cold, it's 38 degrees Celsius precisely. And it stores that number in a little memory slot called a data register.
Now this is the whole ballgame right here. This is what makes smart manufacturing possible. Because those data registers hold the juicy details, the exact temperatures, the precise pressures, the real-time speeds. All that data can then be read by the high-level software, the MES systems we saw earlier. That's how they can analyze performance, spot problems, and even predict when a machine is about to fail. It's all about the data. So look, the goal here isn't to make you a PLC programming wizard. That takes years. The goal is to arm you with the right language, the key concepts, so you can walk onto a factory floor and have a really smart conversation with the people who are the experts, the automation engineers, the electricians.
You don't have to be the one writing the ladder logic. But just by understanding these fundamentals, you become a way better collaborator. You can help connect what the business wants to achieve with what's actually possible on the machine level. So here's your new superpower. You have the vocabulary now. Instead of waving your hands and saying, "We need to know when the thingy gets hot," you can now ask, "Are we capturing the temperature value in a data register?" See the difference? You can ask really specific, intelligent questions that get you to the solution faster.
All right, to really lock this in, here's a little homework for you. Next time you step into an elevator, just stop and think for a second, because you are stepping into a perfect, everyday example of a PLC-controlled system.
Seriously, think about it. What are the inputs? Well, the button you press for your floor, right? And the sensor that makes sure the door is closed, that's the PLC's senses. The brain is the logic that says, okay, door is shut, they want floor 5, let's go. And the muscles, the outputs, that's the big motor that pulls the car up, the smaller motor that opens and closes the doors, and even the little lights that show you which floor you're on. It's all there. Senses, brain, and muscles. Turns out, you've been using PLCs your whole life and probably never even knew it.